Hello guys, welcome to Statistics Bio 7. The channel fully focused on the biostatistics data analysis and data visualization related video post on the channel. If you like the channel video, click to the subscription button and support to me, join to our channel membership. Let's go to the video section. Now we are the discussion topic, confirmatory factor analysis interpretations. How to analyze confirmatory factor analysis in RStudio. That video already published in our channel. That video link mentioned to this video description box. So the continue of the interpretation of confirmatory factor analysis. The confirmatory factor analysis was performed using the lavaan package in R to evaluate the factorial validity of the hypothesized two-factor model that consequence plant stress response into the physiological stress and biochemical stress domains. The model postulated that chlorophyll content, stomatal conductions and leaf area serve as indicators of the latent constructed physiological stress, while proline content, antioxidant activity and lipid peroxidation serve as indicators of biochemical stress. The CFA aimed to statistical test whether the observed data fit this predefined structure by examining model fit indicates, standardized factor loadings and residual variations. Model estimations was conducted using maximum likelihood ML estimation, and model fit was assessed with multiple indicates including CFA, TLI, RMSEA and SRMR to ensure robust evaluation of model adequacy. The first one table for the model fit indicates confirmatory factor analysis. The fit indicates the value and recommendation threshold. The X square degrees of freedom 8, the value 12.134, the p value 0.145, CFI 0.991, TLI 0.98 and the other value present in the table. The detail of the table model fit indicates the I square. The X square value tests the null hypothesis that the model implied covariance matrix matches to observed covariance matrix perfectly. A non-significant result p higher than 0.05 indicates good fit. In your case, X square bracket 8 is equal to 12.134, p is equal to 0.145, acceptable, model not statistically different from data. The comparative fit indicates CFA. CFA compares to the fit of your hypothesized model to that of a baseline independence model. Your CFI is equal to 0.991, which exceeds the 0.95 cutoff excellent fit. Tucker-Levens index TLI, also called non-normal fit index NNFI, similar to CFI but penalizes for model complexity. Your TLI is equal to 0.984 excellent fit. The next one for the root mean square error of approximation RMSEA. RMSEA estimates how well the model would fit the population's covariance matrix, adjusting for model complexity. Your RMSEA is equal to 0.131, which is above the conventional cutoff less than 0.08. However, RMSEA is sensitive to the small sample size n is equal to 30. Additionally, the 90% CI includes 0.000, indicating the population's RMSEA may still be acceptable. The standardized root mean square residual SRMR, the SRMR the measure the average disparity between the observed and predicted correlations. Your SRMR 0.0 0.013 well below the 0.08 cutoff, indicating very good fit. The table 2 standardized factor loadings, the latent variable for the physiological test and biochemical stress, the indicator for the variables chlorophyll, stomatal, leaf area, proline, antioxidant and lipid. The value present in the estimated value, standard error value, Z value, then P value and standard loadings. The detail of explain in the standardized factor loading, the table 2, the estimated, the unstandardized factor loading, that reflects how much a 1 unit change in the latent factor affects the indicator in original units. The example for stomatal contractions loading is equal to 0.998, a near 1:1 relationship. The standard error ZP value. Test if the loading difference significantly from 0. The all indicators are significant, P less than 0.001. All indicators validity measure their constructs. The standardized loading. They reflect the correlations between the latent factor and the observed indicators range from 0 to 1. All loadings higher than 0.97, which is extremely high, very reliable indicators. So the third one table for latent variable correlations. Interfactor correlations, a significant negatively correlated was found between the physiological stress and biochemical stress. R is equal to minus 0.878, the P less than 0.001, indicating that the higher physiological stress indicators are associated with increased biochemical stress marker in the table 3 present. The latent variable for the biological stress was biochemical stress. The correlations value minus 0.878, the standard error 0.233, Z value minus 3.586, the P value less than 0.001. The fourth table for the residential variations of indicators. The indicators, the presence for the variations, same for the variables, the chlorophyll, stomatal and the leaf area, proline, antioxidant and lipid. The residuals value, standard error, Z value, the P value present in the table. The table 4, the detail explained for the residual variations. The proportions of variations in each indicator not explained by its latent factor, the measurement error or uniqueness. For example, the lower is better, the means indicator is better explained by its latent construct. The chlorophyll content and antioxidant activity have very small residual variations 0.006, 0.001 and non-significant P values, indicating negligible error, highly reliable indicators. Other indicators, stomatal contractions and leaf area, proline, lipid productions have small but significant residual variations, meaning that although they are reliable, a small proportions of that. So the figure 1 interpretation of the correlation heat map. The correlation heat map displays strong intra-factor and inter-factor relationship. Within the physiological test indicators, the chlorophyll content, stomatal contractions and leaf area, the correlations were nearly perfect, R is equal to 0.98 to 1. Within the biological stress indicator, proline content, antioxidant activity and lipid productions, correlations were also the extremely high, R is equal to 0.96 to 1. And between the physiological stress and the biological stress indicator, strong negative correlated was observed, R is equal to minus 0.86 to minus 0.90, suggesting a potential inverse relationship between physiological and biochemical stress response. So the second one figure for the path diagram, the CFA path diagram visually confirmed that the hypothesized two-factor structure is extremely supported, empirically supported. The strong standardized loadings 0.98 to 1 were observed on all paths from latent construct to their indicators. A strong positive correlation is equal to 0.088 was observed between the latent factor, physiological stress and biochemical stress, indicating that although theoretically distant, the two constructs are highly related in the context of plant stress response. So the final of the conclusions, the CFA of interpretations. The result of the CFA conducted in are demonstrated that the hypothesized two-factor model exhibited excellent fit to the data, as evidenced by the high value of the CFI and TLI and low value of RMSEA and SRMR. All factor loadings were strong and statistically significant, supporting the convergent validity of the observed indicators for the response latent constructors. The low residuals variations indicated the minimal measurement error, and the strong positive correlations between the latent factors suggest a close relationship between the physiological and biochemical stress response. Overall, the CFA finding confirmed that the measurement model is validity, reliable, and theoretical sounds, justifying its use in further analysis examining plant stress physiological. So this is for the confirmatory factor analysis interpretations. If you any doubt on the interpretation of the confirmatory factor analysis, leave me comments in the comment box. I will reply to you. And if you like this video, click to the subscription button and support to me, join to our channel membership. And additional detail I will explanation for the confirmatory factor analysis full R code I will explain in our Blacker page. That page link also mentioned to this video description box. Please visit to our Blacker page. If you want the code, get the code. Okay, thank you for watching this video.